I see, I remember you, if you remember me.
Hello friends, welcome to 7-minute study. In this video I'm going to talk about what is a compiler and what is an interpreter and how a language processing system basically works. So let's start with it. First, before going to language processor or learning about compilers, first let's know what's the reason for introducing compilers. The concept compiler has been introduced in order to convert some language or some instruction we give to the computer into a language with which the computer would understand, computer or a machine would understand. So what's the need for writing what's the need for designing a compiler basically? We have programs, right, which is a set of instructions which gives which gives a machine some instructions or a set of instructions based on which it has to perform a particular task. So we write a program which is accepted by both the computer or the machine and understandable to human. Okay, so what's a programming language which we use to write the program? A programming language is nothing but a notation that is used to describe some computations to people and also to machines. Okay, so to make these programming languages or programs more understandable to the machine, we introduce another set of instructions which are stored in a default manner in the system, which is known as a compiler. So what's a language processor basically? A language processor is a program that can read program in one language, which is the source language, and translate it into an equivalent program in other language, that is the target program. We have most famous two types of language processors, which are the compiler and the interpreter. What's a compiler basically? So in a compiler we have the source program which is written by the human or which is written by the people, which are fed into a program which is known as a compiler, which generates a target program. Where after the target program is generated, now the target program is running on a system which is given some certain input which produces our desirable output. So this is running the target program. Okay, this is how it looks like. What's basically happening? I will explain it with an example. Let's say our source program is going to print is written in C language. It's a C compiler, so the source program is written in C language .c. Let's say hello.c, in which we print hello world. Okay, so we use printf hello world in this. After following all the necessary statements in the main, we print hello world. Okay, so after we generate this, some target program which is understandable to the machine, to the inner work of the machine, is generated. And to this target program, if we had some scanf, here we don't have any input, so no input, it will be generated directly the output, that is how hello world will be printed on our command prompt. Okay, in fact, instead, if we had some scanf task, we have to give some input to the program. Okay, after compilation we get the target program, that is after .c file has been generated, we will get some file, right? After that we give .a.out with if it is executed without any error, so we give an input and we get the output a plus b. Scanf a and scanf b, a plus b, 2 and 3 we get the output as 5, right? If we find out no errors in the program execution. Okay, so as I talked now, what's an important role of a compiler? It is to report any errors in the source program that are detected in the processing of the source program. If we have some errors, the target program won't be generated. Okay, an interpreter is another similar kind of language processor which directly takes source program and input directly and produces the output. So as it takes our source program and input together directly, it's a very fast process. It's a very fast language processor, and error diagnosis is a little more faster and easier, but we can't say it's very accurate. Sometimes this, most of the times, interpreter has more accurate error recovery or error diagnosis. So let's now go to another concept known as a hybrid compiler. What's a hybrid compiler? A hybrid compiler is nothing but a language processing system which uses both, which performs both the tasks of, which acts as both like a compiler and an interpreter. Let's consider a Java language processor. In a Java language processor, as we know that source program is given in terms of .java file, okay, in the form of .java file, and it translator converts a translator or a compiler, or an interpreter directly converts it into an intermediate program which is made up, which is in the form of what, dot object file. It's an executable object file, okay, dot class file, okay, or dot class file, okay. So what happens here, we get some byte codes, okay. These byte codes are directly converted with when given to input to the virtual machine or the Java virtual machine, we get the required output, okay. This is what happening in a hybrid compiler. This is the structure of a hybrid compiler, how it looks. The source program is given to the translator, okay. It's a mixture of both compilation and interpretation. That is, the first we get the byte codes or intermediate program from the compiler. This is the compiler, sorry, this is the interpreter basically, okay, interpreter, and then we give this byte codes and the input together to the Java virtual machine, to give the output. As we are this intermediate program is given to any Java virtual machine present on any system, or a virtual machine present on any system. That is, you write a code on your computer and you generate the .class file and you give the .class file to your friend to run on his own machine, on his own virtual machine. It then also generates the same output. So it's also known as, so Java language processors are also known as just-in-time compilers, because even after we give the intermediate inputs to an intermediate program along with an intermediate program to the virtual machine, we get the required output. So that's what that's why the Java language compilers are also known as just-in-time compilers. Thank you for watching the video. If you have any queries or if you have any suggestions, please mention it in the comment section. Thank you.